Stream is starting, the Captain Coder at the helm. Bean water is ready. Today we will learn a lot. He loves the questions, he loves to sing. Join our Discord and follow him.
Good morning, good afternoon, good evening to you, Captain Coda, here on this beautiful Friday. Welcome aboard, welcome to Captain Coder's Academy, where we have bean water, fresh water, and lots of terrible singing. I'd like to welcome the whole crew today. Welcome aboard. Today's a beautiful Friday, folks, December 22nd. Today we will be doing Advent of Code Day 22 Sand Slabs. But before that, I want to welcome everybody. Happy Friday, everybody. It's so nice to see you. Good morning, good afternoon, good evening, wherever you happen to be in the world. I hope you're having a beautiful day. Code Monk says, how's it going? Are we ready for some more AOC Oscars? We're doing our best. We're going to do our best. We're going to go, whew. Man, day 21 almost ended me. Day 21 almost ended me. I ended up writing, I think it's important to go back and show my solution a little bit to that one, how I got there, because boy, was it wild. Spoof says, today seems similar to the Tetris one from last year. Gotcha. What we're going to take a look at in just a moment here, but I want to say thank you to Corfless. Happy Friday. Hope you've been well, my friend. Clayman, welcome back to the stream. It's nice to have you here. Spoof, welcome back, Spoof with that rust, that high speed, hyper vigilant, fast solutions over there. We got Smab as well. Smab, I was trying to go look at Smab's solution. I was so confused. I was trying to look at Smab's solution, and I came down here and I just clicked on day 22 on accident. So I had a gander at this and I was like, what is going on, bricks? So I know that there's bricks and supported by stuff. So I accidentally looked at Smab's solution. I didn't look too long. I was like, oh no, I meant to go to day 21. But my solution, Spoof, my solution for yesterday is, I gotta show it. But Dirty Puddle, it's also nice to have you back, my friend. Moon is welcome aboard. How the heck is the moon? How's the moon holding up for you, my friend? How's the moon holding up? Oh, wait, that's no moon. That's a zoom in. And Code Monk, it's nice to have you here. My solution yesterday, essentially, and it might be kind of hard to look at here. This is what my solution is a strong word. Nick, welcome back. Solution is a strong word. I ended up doing I solved it for the sample input as well, which comes out a bit differently. I don't have a solution that you can like do a run to do it. I ended up calculating it essentially by hand, discovering the pattern. So if the radius, Let me show a little bit of this. This is wild here. I ended up writing program would generate output that looked kind of like this, so that I could look at, okay, how is this thing expanding out? How is this thing expanding out? And then counting the patterns that occur internally and on the edges, right? So I have this sort of crazy thing that I did here. I ended up saying, okay, well, what I can do is each one of these grids, it's pretty challenging. Each one of these grids here, I can take it and I can just hash. I take this string here, so I don't write a bunch of helper functions. Say, okay, can I print just a chunk of a grid? I take these helper functions. One thing to notice, and my intuition here was correct. I don't know if you guys remember, the number of patterns I had initially was incorrect. So these two things are the same. So on the inside, we have a checkerboard pattern of grids. And then on the outside, we have some special cases. And it turns out for our puzzle input, I just did part one because it looked easy to get a result, even though it ran for about 2 seconds. Gotcha. I'm not sure if you're referring to today or yesterday. And so I ended up writing this thing, and you could print this out with the big input. Here, let me show you that. Maybe I can do it still. Essentially, what I ended up doing was saying, okay, each one of these patterns, I gave a label. Each one of these patterns I gave a label, so 0, 2, 9, 12. These are patterns. These ones, I mapped out the occurrences as the radius increased. All right, so notice this is an even, this number here, 4, 6, 8, 10, 12, 14, is the number of, is the size of the radius. So the center grid would be a radius of 1. It would just have the center grid. A radius of 2 would have a 3 by 3, 3 by 3 grid. So it's how many spaces out we go. And so as our radius increases, the number of occurrences of each pattern increases. So these are sort of the special edge cases. These are the edge cases on the diagram, 0, 2, 9, 12. This is the top, left, bottom, and right. It is always 1 when our radius is of this size. These are, again, the edges here. So these increase 2, 4, 6, 8, 10, 12. So these ones, I came up with the formula here for elf radius minus 1. These all just have 1, elf radius minus 2. And then these ones increase using square. So this is 3 squared, 5 squared, 7 squared, 9 squared. So it's increasing by 2 as we go, but our radius minus 2. So I was able to calculate this. And then this took me an insanely long amount of time to debug because I had this as an int here. Originally, these were ints, even though I had my sum here as a long. Oh my goodness. I could not figure out what was going on. I kept getting a number over here. And then I finally did a debug and step through, and it was overflowing. The square here was overflowing. So it was such a mistake. This also works for the sample inputs. It's just the radius is calculated differently for that one, because you got to determine when the cycles start happening. This is how my system works. You can write code to discover. Yeah, exactly. Code Mug. And I was going, well, I could probably write code to detect these patterns, but I did write code to detect the patterns, but I did it manually by hand. Smab, I know it was bad news, man. It was bad news. I spent 2 hours going, I must be counting these wrong. I must be counting the number of O's wrong here. And it was horrible. It was horrible. Mizzard, welcome back to the stream. Thindle, it's so nice. Whoop-de, whoop-de, doop-doop, whoop-de, doop-doop-doop. That's right. That's right. So I just assumed that my O count was off, and I was looking at all kinds of stuff. I wrote an insane amount of code in here. That is just like the gnarliest of code. So my day 21 is nasty. It's nasty. It was not an off by 1. I had it right. It was an off by long. It was an off by 30. It was off by 32 bits. Then there was an off by 32 error. Was just to widen everything to I-128. Gotcha. Yeah, it was an off by 32 bits. problem for me. Finding a pattern on those. Oh yeah, sorry, I already read that one. All right, folks, what are we doing today? Sorry if I missed something. What are we doing? What? I know in Java it'd be a big int. I wrote about 1K lines of code until I got a good solution. Gotcha. After that, I deleted almost all of it. My day 21 didn't conclude yet. Gotcha, Nick. I don't have, so my program doesn't actually take in an input. So I've hard coded my solution here through eyeballs. I eyeballed my output and said, you know what? How is this going? Because I looked at my output and I said, okay, we have 14 total patterns. When our radius is even, we have 14 total patterns. When our radius is odd, we had 13. For our sample input, it was like 18 and 19 or something like that. And so I said, okay, well, let's find all of our different patterns. And then I said, as we grow, what are how big does this pattern grow by? And so we went by, that's essentially how I did it. And I eyeballed it rather than discovering the pattern programmatically. I eyeballed it, was like, I'm done with this. And we did it. So we got a little bit of a solution there. Exactly, Nick, that's essentially what I have here. But it works. Yeah, it does. It was, so mine runs in almost, mine runs in microseconds. It doesn't do much. It's a snob. C# also, does C# have a big int? It's bounded by your address space. What is, Kovalaki, welcome back to the stream. All right, folks. I am coding chemist. Also, welcome back. System.numerics.bigintro. Gotcha. Usually, if you're using that, you're probably in trouble. All right. So we're gonna do day 22. I've seen, but did not study a solution. I was looking at a solution for day 22 on accident this morning. I was trying to look at SMAB solution to day 21, and I clicked day 22. And so I was looking at it thinking it was a solution for day 21. SMAB had mentioned yesterday that he was planning to do something with, he had a theory that you could do something with these, with the number of hashes in there. And I thought like you had a bricks and stuff. So I didn't quite understand. I was like really confused. And then I realized I was on day 22 at the last moment. So I have a little bit of an inkling of what this puzzle is, but not much. So I'm just gonna come clean, to be honest a little bit about that. Also, Kavajra Tisk, I'm so glad to have you here, my friend. Welcome back. Feel free to get those jabs, get those critiques, and get those criticisms in. But what? All right, folks, I got to do a pin. What are we doing today? What? We are working on day 22. Advent of code. We're day 22. We're on day 22. What did I say? All right. Sand slabs. Enough sand has fallen. It can finally filter water for Snow Island. Well, almost. The sand has been falling as large compacted bricks of sand line up to form an impressive stack here near the edge of Island. In order to make use of the sand to filter water, some of the bricks will need to be broken apart, nay, disintegrated back into freely flowing sand. The stack is tall enough that you'll have to be careful about choosing which bricks to disintegrate. If you disintegrate the wrong brick, large portions of the stack could topple, which sounds pretty dangerous. The elves responsible for water filtering operations took a snapshot of the bricks while they were still falling, which should let you work out which bricks are safe to disintegrate. For example, 10112102202232232320242252162161181181119, etc. Each line of text in the snapshot represents the position of a single brick at the time the snapshot was taken. The position is given as two XYZ coordinates, one for each end of the brick, separated by a tilde. Each brick is made up of a single straight line of cubes, and elves were even careful to choose a time for the snapshot that had all the free-falling bricks at an integer position above the ground. Man, those elves are clever with their snapshots. What are the chances? What are the chances? Yeah, we need a TTS of that 101110111. Also, Sijian, welcome back to the stream, my friend. I hope you're having a beautiful day. Thank you for the first. Folks, don't forget to get your bonus points. Exclamation point first. Get them in there. Get them in there. You know you need them. You know you need them. The elves cleverly managed to get the integer positions. Is hilarious to me. So the whole snapshot is aligned to a three-dimensional cube grid. A line like 22222 means that both ends of the brick are at the same coordinate. In other words, that brick is a single cube. Lines like 0, 0, 10, 1, 0, 10, or 0, 0, 10, 0, 1, 10 represent bricks that are 2 cubes in volume. Okay, so it's inclusive. It's inclusive. Is that correct? It feels inclusive. Both oriented horizontally. The first brick extends to the. Thank you guys for the first. Oh my god. Oh my goodness. Apila Tosoba. Apila, welcome back to the stream. How you doing, my friend? Hope you're having a beautiful day. Thank you for queuing up your solution. We're gonna see if we can get to some solutions today. Yeah, these are inclusive here. A line like this represents a 10 cube brick, which is oriented vertically. One end of the brick is the cube located at 001, while the other end of the brick is located directly above it at 0010. The ground is at z equals 0 and is perfectly flat. Oh, we're gonna have to write collision detection. Thank you for Tyndall. Thank you for the what. Folks, if you guys don't know Tyndall, the incredible Tyndall, host of the Captain Coder Wat. We got the collectible Captain Coder emote. You can get it over at Tyndall's stream. Give him some love, folks. Be sure to give him some love. The ground is at z equals 0. It's perfectly flat. The lowest z value a brick can have is therefore 1. So 551, 561, and 021, 025 are both resting on the ground. But 332, 333 was above the ground at the time of the snapshot. Okay. Because the snapshot was taken while the bricks were still falling, some bricks will still be in the air. You'll need to start by figuring out where they will end up. Bricks are magically stabilized, so they never rotate, even in the weird situations like they're magical Tetris bricks. They don't topple. Andrea Coluzzi Dev. Andrea Coluzzi Dev. I would like to welcome you today, Andrea. Oh, Andrea, thank you for following me. Thank you for the follow. Welcome to Captain Coder's Academy. Oh, it's going to be a long morning, folks. Captain Coder is a little bit sleepy today. I didn't sleep that well last night. I didn't more Tetris than Jenga. Yeah, this feels like the way they hover in air is Tetris, so they never rotate even in weird situations. Popcorn, welcome back to the stream. It's nice to have you here. What have you been up to, Popcorn? 2 bricks cannot occupy the same position, so falling brick will come to rest upon the first other brick it encounters. Folks, if you haven't played Tricky Towers, Tricky Towers is a Tetris-esque game. This is one of my favorite games. I love Tetris, but Tricky Towers is, what if Tetris had physics? What if Tetris had physics, and if you didn't line the bricks up perfectly, gravity would pull them? This game is hilarious. Highly recommend. Tetris, but with physics on your blocks. Tricky Towers, one of my favorite games of all time. Okay. Popcorn says, I am just learning basics in Rust, still forever noob. How are you all? I'm absolutely wonderful. I am super noob at Rust as well. I really want to get good at. I would really like to have time to do some more Rusts. You know what my favorite game of all time is? Thindle, what's your favorite game of all time? I don't know. If I had to guess, I'd say MS Paint. But that's just a guess. It's a pretty good game. It's poorly assembled. Oh, Thindle, oh, you trying to get. You're my favorite, Thindle. That's why. Look, Thindle, for stroking my ego, 500 points. 500 points. The poorly assembled game. What do I have here? Jern Jam 2. Is that what we do to get it? If you guys haven't seen the poorly assembled deck building game, feel free to check it out. It's a game we are making here on stream. We made it in 10 days for the Jern Jam. All right. They never rotate. Okay. Here's an example again. This time each brick is given a letter. XYZ. So the question I have, do we always have the lower end on the left side? That would be helpful. It doesn't specifically say that, but I would like the lower numbers on the left side, so I can sort them. So I have this idea that if I sort them and then have them fall one at a time, okay, we can get them down to the bottom. Yeah, it's always low high. Gotcha. Okay. I guess you could sort them out or something too. But here's the representation they gave us. These bricks are arranged like this. Oh, this is the starting arrangement. I was like, what is going on? Why is there space between them? And then once the bricks fall downward, they fall into stacks. Okay. Now the bricks have been settled, it becomes easier to tell which bricks are supporting which other bricks. Your first task is to figure out which bricks are safe to disintegrate. A brick can be safely disintegrated if after removing it, no other bricks would fall further directly downward. Don't actually disintegrate any bricks. Just determine what would happen if, for each brick, only that brick were disintegrated. Bricks can be disintegrated even if they're completely surrounded by other bricks. You can squeeze between them. I don't think they've seen Captain Coder's girthiness. I don't know if Captain Coder could squeeze between the bricks. Look, they're making some big assumptions here about how squeezy I can get. In this example, the bricks can be disintegrated as follows. Okay. Cannot be disintegrated. So in the example above, 5 bricks can be safely disintegrated. Santa manages it. Oh no, Slabs onto me. You may have noticed you've never seen Captain Coder and Santa in the same room before. I'm gonna go disassemble a spaceship real quick so you're all on my number 2 monitor here and listening though. Thindle, enjoy your work. I hope you enjoy your lurking work. All right, so we got to figure out how the blocks will settle based on the snapshot. Once they've settled, consider disintegrating a single brick. How many bricks could be safely chosen as one to get disintegrated? Okay. All right, folks. Coding chemist, you're the best name in the stream. Coding chemist. How you doing today, Coding chemist? It's nice to see you. What have you been up to? Were you here already? What's going on? My didn't log your name in my chat for some reason. Git add, git commit, chore, initialize, day 22. All right, folks. Let's create a new day 22. Public class day 22. Public static long part 1 string input. Public static long part 2 string input. Return 0. Return 0. All good. Last day of work before the holidays. Well, I hope it's a beautiful day for you. I hope you're excited for the holiday. I know I am. I am finally done with the cursed house, and we can finally move on and live our lives in the new house, which is feeling not so cursed. We're loving this place very much. But yeah, the cursed house. The saga of the cursed house, I believe, is over. All right, so we're gonna get a sample input here. Public const string sample input. If you overflow today, you've done something very wrong. No trim on this. Well, Smab, you don't know my ability to overflow. Smab, it's like you don't even know me. It's like you don't even know me. Look, if I can overflow if I want to. I can leave my ints behind. I can't come up with the rest of those lyrics though. Come on, just the curse wasn't the house, the curse was the captain himself. Don't say that. No, I am not built on top of a cemetery. I was not built on top of a cemetery. The last house was crazy, man. I don't understand all the things that went wrong in that last house. I'm not superstitious. I'm just a little stitious. In that house, there was something about that house that just everything just kept going wrong there. But yeah, Smab, my overflows no bounds. Woo! I kill myself. I slay me. All right, so we're gonna do day 22. Part 1 sample input shouldly be 5. Okay. This is gonna be test sample input part 1. Okay. Let's do it to it. Let's make sure that this runs. We need to parse the input here. We need a brick. So these all we need we're gonna need to see if 2 bricks like intersect with each other or something. How tall is how high do my bricks go? They go not too high. How many bricks do I have? Hang on, let's find out how many bricks we have. There's quite a few. Can we save input.txt here. Word count, implementation, input.txt. There are, it's telling us the number of lines, right? 1,322 bricks. 1,322 bricks. It looks like the max height is like 300. Yeah, the max height is like 300. Okay. So these bricks, all right. Let's put this in the test folder here. The question is, here's what I'm doing. I should probably build up a dependency graph of these things, since we need to know how they lay on top of each other. But the question is, how many brain cells do I have today, folks? On a scale of 1 to 7, how many brain cells does the captain have today? So I don't think I'm if I don't look ahead to part 2, negative infinity, thank you, Kamadra. If I don't worry about part 2, I can just be like, all right, let's sort them by the ones that are lowest, and then we're just gonna drop them. We're just gonna drop them one at a time. Yeah, but I'm running on fumes today, man. We're on day 22. We're getting ground down. We're getting milled down on this one here. Can we do it for each? All right. So I'm pretty sure it's not too bad. Worst case. All right. Calc. Do I have calc installed? Oh no. I wish I was on Linux. I like Linux's programming calculator here. All right. So we have 132. This is what my brain wanted to say. We have 1,322 bricks. and we need a loop over every brick, and then every brick we're gonna have it fall. Why can't I do a multiply? Our max height is 300, so we can do this many iterations. We can do this many iterations to have them fall. So to have all our bricks fall into place, we need to do about this many loops. About this, this is our O of, this is our O of 1, our constant is this. So it's an O of 1 operation. The constant is just about 400,000. So it's O of 1. It's O of 1, 400,000. Let's do it. Let's do it. All right, let's do a parse here. We're gonna create a public public record brick. It has a 3-dimensional position, which I haven't come up with. Let me drink some more coffee. Buckville, welcome back, and Kuani, it's nice to see you. Hope you guys are both having a beautiful day. Let's do a public record position 3D. Int X, int Y, int Z. Okay, and we have lower and upper. So I have a position 3D lower and a position 3D upper, like this. Public static brick parse string row. So rows coming in, the row looks like one of these. Pretty simple parsing here. And we will do string parts equals string row dot split on tilde, and then we will do a int array left is equal to parts of 0 dot select int dot parse. Like that. Come on, let me do the thing. Why won't you let me do you? Let me do the thing. Why? Should this be a string? Parts of 0. What is parts of 0 dot select? Oh, it's having it be a char? Dot split on comma. There we go. Right. And then we return new brick. Left 0. New position. Left 0. Left 1. Left 2. New position. Right 0. Right 1. Right 2. Okay. So we get a brick here in this way, and then we're going to go through and do a public static list of bricks. I guess I could do an I enumerable of brick parse all string input, and we'll do should be parts of 1. Oh, thank you, Smab. Thank you for making up. Look, without the incredible crew, I would never, I would not have enough brain cells. The brain power is at an all-time low. Points at Smab. Bonus points. Thank you so much for your help, my friend. All right. We are going to do input.replace line endings dot split on environment dot new line. Dot select brick dot parse dot parse, and we'll return that. All right, and because we one lined it, boom Boom, chicka boom, chicka 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 boom. And it says I can get rid of that. All right. Boom, boom. Okay. Okay. I think we have our parse. Pretty straightforward parse. We'll do a sanity check here. Sanity check. Check 1, 2. Check, check. Fact. Public void test parse all. Brick dot parse all. Sample input. Looter, welcome to the stream. Is your goal just to finish the challenge? You're trying to do it in a certain way. I'm just trying to finish. I'm not any kind of I'm not a hardcore AOC person. I'm pretty tired today. My goal is to just finish today. My initial thought is that for part 1, the solution's simple enough that I don't think we have to build a dependency tree. Part 2, I think I haven't seen part 2 yet, but my thought is that we're going to want to have a dependency tree for part 2, but I'm not going to do one for part 1. I'm just going to simulate disintegrating bricks and seeing which bricks fall. So if we disintegrate bricks and then any bricks fall, that means we count it. Whoa. Miss Pixie. Oh, Miss Pixie. Thank you for the raid, Miss Pixie. I hope you're having a beautiful day, Miss Pixie. How are you today? Folks, if you guys don't know, Miss Pixie, incredible streamer, incredible programmer. Learning, what were you working on, Miss Pixie? I know last time we spoke, you were doing some C# stuff for school. No worries, Miss Pixie. Have a beautiful day, folks. Be sure to give Miss Pixie some love. Go check out what she's working on. Incredible streamer here on Twitch. We love her. It's the caffeine Senor Pantalone. Senor Pantalone. It's the pants guy. It's the Pantalone guy. Welcome back. It's nice to have you here. We are doing Advent of Code. What are we doing? We're doing the Advent of Code day 22. There's 4 days left. 4 days left. We almost got all the stars. If you're not familiar with Advent of Code, it is a series of puzzles that are released in December. They start easy and get slowly more difficult. But Senor Pantalone, Blackter, and Limey Orange, thank you guys so much for being here. Thank you for the raid again, Miss Pixie. Have yourself a beautiful day. Hope to see you again soon. All right, folks. Oh, that bean water is good. We might need to take a break and get some more. I know we haven't been going very long, but I'm feeling the sleepy. I'm feeling the sleepies coming along. We were writing a IEnumerable brick here. We just wanted to we're doing a sanity check here, bricks. You know what, I'm gonna do this. I'm gonna make this an brick array here. We just want to make sure we have all of our bricks there. 1, 2, 3, 4, 5, 6, 7 bricks. Bricks dot count dot should be 7 length. And bricks dot should be subset of new brick array. I don't think I need to make all of these. Let's do a new brick, new position 3D. 1 second. I'm gonna make this a convenience thing for me. Let's go to our AOC helpers. I can't remember exactly how I did that. Come on. Oh, too far. CD AOC helpers. Position here. I just want to still a little bit from this. Implicit. Here we go. This is what I want. Given a pair. Yeah. So I want to still this thing. To make my life slightly easier, position 3D can take in an X, a Y, and a Z, couple, and it'll return a tuple X, tuple Y, tuple Z. Okay. I want to be able to do this, and so now I can do this without having to do a new there. Let's make this a struct as well. For funsies. So now I don't have to type out new. All right, so now I can just do 1 0 1 1 2 1. So constructing these is a little bit easier now. All right. 0 0 2 2 0 2 0 2 3 2 2 3. JD, how you doing, buddy? Welcome back to the stream. Happy Friday. Hope you're having a beautiful day. JD, I think you mentioned you had a new job. I wasn't sure if it was a full job, a part-time job, a contract work. But I've been meaning to ask you how that job is going or went. Because I was excited to hear that for you. 0 1 6 2 1 6 1 1 8 and 1 1 9. All right, full-time principal software engineer at a major insurance company. Fantastic. I'm glad to hear that. I hope you enjoy it. I hope you're enjoying it. Or at the very least, getting paid to do it. At the very least, getting paid to do it. But yeah, JD, welcome back, folks. If you guys don't know JD, incredible software developer, engineer, a human being.
If you want to feel...
Be sure to give JD a follow, folks.
Let me see if I could do my captain impression. I am not the captain, but my eyebrows also move in a way like the captain.
JD, I'm looking forward to your updated video. When you get it, feel free to send it to me. I can't promise I'll get it updated anytime soon because I've been getting worn down on this by January probably. I know you had mentioned you have a new clip for me. I'd love to put it on there. Haven't done anything in 3 weeks. They're making it very difficult for me to work with all the restrictions on my laptops. Oh yeah, last time I thought you said you were gonna do something. Look, if you're happy with it, I'm happy. If you're happy, JD, if you're happy, I'm happy. JD does happy, folks. JD does sex. JD does it all. Okay. It's if you didn't look. I only have a couple brain cells left today. Exactly. That's the one, JD. That's the one. All right. So our parse is working. I want to make a sort on this, and so the easiest thing to do would be have a sort comparable. Comparable. Is this how we do this? How do we do compares in C#? In Java, you would do I want to do an I comparator or I comparable? Let's look up C#. Implement C#. Class implement sort. Let's see here. Making a type sortable. Equatable. Okay. Equatable. So can I do equatable of another brick? One of the things here, I want them to be sortable though, Thindle, not just equatable. I think I need to do, let me go look at equatable. Equatable is just equals. I comparable. Okay. I comparable. Okay. So this will say given 2 bricks, which one is greater than, which one's less than. So we're going to implement it so that they're sortable by their Z position. Are ints comparable? So we can, if that's the case, we can just return return 5 dot compared to, yeah. So we can do, this becomes pretty easy because I can do lower dot z dot compared to other dot z. Other. Can I say that? I promise. I promise. All right. It wants the null thing in there. I really wanted to do that. Other. Why can't I do the? Or did I do this? Do I do this? Compared to requires me to pass in an int. Brick does not have a definition. Oh, dot. Hang on. Lower. There we go. Look, I already claimed my brain cells are low. We're just another brick in the wall. Prophets TV, it's true. We're just another brick in the wall. Box Kuva, thank you so much for that. I appreciate it. I was going, I'm losing my mind. Box points and a box of Kuva. 50 points to you, points. And Occluder, thank you so much for the help. 50 points to you beautiful people out there. All right, so we can compare these things. And then we should be able to do a sort on them now, right? Can I test? I want to test if I sort my list by their lower Z index. Okay. Now I want a brick tower, public record tower, has a, I'm going to just make this a list of bricks, and maybe I should make it a class. I feel like this, making it a, oh yeah, we have default constructors now, right? That's interesting. I want to, when we get the tower, I want to go ahead and sort it. Public tower bricks, like this. Public. Hang on. So a record typically would be immutable. So this feels a little bit bad. I can sort them. Okay, let's sort them. Come on, Brain, you can do it. You can do it, Brain. Public void fall. So I kind of want to do this where we take all these things. What's going on? Why is the record? What task are you trying to solve? Great question. No problem. We're doing Advent of Code day 22. Day 22. Okay. I like the syntax of world.accept brick. Kuwani, 2 minutes on your runtime for part 2. We're on part 1 right now. We're going to see where we're going to... This is why I was saying I probably want to have a dependency graph. All right, so Limey Orange, we have... A picture might say, look, there's like 1,000 words type, but if I drew a picture. But we have these 3-dimensional rectangles, cubes. They're not cubes, they're rectangular cubes. We have these 3-dimensional shapes coming in. Well, I bumped my Stream Deck there while I was trying to set up. Let me see if I can do a drawing here for you. Let's go to the .chem. So we have these 3-dimensional... Hang on, folks. Slide it out. Slide out my remarkable... Oh, I have 13 battery left. We might... All right. So we have these 3-dimensional bricks falling. So we have this input that we're parsing in, and we have these 3-dimensional bricks. Can I switch to... Let's create a new journal real quick. New notebook, no name. I want it to be hexagonal grid. Where's my hexagonal grid? Isometric will work too. Okay, create. All right, so we have these 3-dimensional bricks that we are pulling in here. So we'll have these 3-dimensional bricks. They are taking up some amount of units. So we have these 3-dimensional bricks. Coding on a Kindle, it's almost. It's a remarkable. It's kind of like a Kindle. So we have a bunch of inputs here that tell us what we have. So we have a bunch of cubes. So they can be cubes, they can be rectangles. So let's make this one a little bit taller here. We have a bunch of inputs here. We could say that this would be a cube here. This cube is going to fall. So they want us to take all these cubes. So we have a bunch of different cubes here. We have their X, Y, and Z locations in the air. So it's a picture of a bunch of cubes in the air. And we need to determine after they fall. So we're going to simulate them falling. And then we need to determine which bricks can be removed without the tower falling. Yeah, so we're using the Remarkable 2 here. So that's the problem we're trying to solve, is we have these cubes that we parsed in. They fall, so we're simulating the fall. And then we are going to, I'm going to do it for part 1. I'm going to do a really simple thing where I just go through every brick, remove it, run fall, and determine how many bricks fell. When you remove a piece, if any bricks fall, that means that that brick can not be safe removed. So we need to calculate which ones can be safe removed. I hope that answered your question, Limey Orange. Let me know if it did not. But yeah, that's what we're working on here. One second, I got to charge my Remarkable here. GN Lumele. Thank you for following me today. We got GN Lumele. Welcome to the family. I'd like to say thank you so much. Thank you for being here, and thank you for following Lumi. Gian Lumele 19. Sorry, I messed up the name there. I was looking away for a second. But happy Friday. I hope you're having a beautiful day. Folks, I'm going to plug in my Remarkable real quick. Thank you for the WhatsApp. That way everyone knows what we're working on. But yeah, day 22 Advent Code. You can find the full puzzle description at that link in the pinned or on the chat there. But GN, let me know if I'm pronouncing that correctly. If I'm not pronouncing it correctly, let me know. I want you to feel welcome here at Captain Coders Academy, and one way I can do that is pronouncing your name correctly. I'm going to open this window if it's spicy in this room. All right. Oh no, Spoof, that's the worst. Okay. So... well, that never happened before. I know. Smab, I've been really lucky this year. Last year, I remember that happening quite a bit. Your part 1 is hilariously slow. Oh, no. So it's telling me I think I need to have a... All right, let's make sure... I'm going to test my sort real quick. Let's test my sort. Fact, public, void, test... Public void, test, sort... test sort bricks. All right, so we're gonna have this be our bricks. Brick array bricks equals this. Sort. Why is there not a sort? Is it order by? Order. There we go. And I think I can just do this, right? Doesn't like that. There's no target type. Slow premium takes approximately 1 second. Yeah, it's true. Spoofs. Your constant's just big. That's what I've decided. 1 second. Can I do this? Okay, I can do that. What is order? Is this is like not a method? Hang on. Bricks dot order Why? Interesting. Bricks sorted is equal to this. And then we want to say bricks of 0 should be oh, is this one already? This one's already in the correct order. Let me mix it up. We're gonna mix it up, folks. Boop. Let's shimmy this around here so that it's nice and mixed up Mother Goose style. Okay. Now we're gonna be out of order. Random.shared.shuffle. Occluder, I'm so sorry about that. Permit occluder. It tries to block links. It thinks anything with any two words together with a period between them is clearly a link. Once you've been in the stream for an hour, it will stop doing it. It basically prevents. We've had some bots come in here in the past. So, all right, but we could do dot. Hang on. Random.shared. You were suggesting I do shuffle. There's a shuffle. Is this shuffle new? Shuffle is new. Does this shuffle it in place or does it return? It does shuffle. Yeah. Okay. I don't ever remember there being a shuffle. For instance, in place shuffle of an array. Okay. There's no reason to shuffle it right now, if I'm being completely honest. New in .NET 8. Yeah, I just need it to be out of order here. We're gonna do a sort, essentially. Gotcha, yeah. I've always had to write my own shuffle in the past. Okay, so this should be essentially in this order. Believe someone correct me here if I'm wrong. Brick 0, bricks of 1. Let's do a thing here real quick. Let's see if we can utilize the powers of the multi-cursor. Bricks of, and why would you do this to me? Equals. Boom. And then I can come through here. 2, 3, 4, 5, 6. Why not just use array.sort? I could do that. I could do that as well. Sorted. Because array.sort bricks. This does it in place. This does it in place. All right, I like it. I like it. Bricks. Okay. Let's test our sort. To the Cupid Shuffle. I am missing a curly brace or have an extra one. There we go. I'm sorting by the Z index, the lower Z, the minimum Z. There we go. He's at a default comparer to the sort by Z. Yeah, so we compare. They get sorted by the lower Z value. Okay. So I know that they'll be in there sorted. So you have our list of bricks. Can we do a list.sort? Fall will do a. Let's. I'm gonna make this a class for. It's what my brain wants to do right now. It's what my brain wants to do, folks. Tolus. Please don't give me a fine. I promise to pay the toll today. We got Tolus. welcome aboard. Were there assertions in your sort? Probably. No. That should be. Thank you. Thank you, Tolas. They were not. They were not. I was just assigning this. Like, look, let's make these. Should be. Look, all my brain. Look, I'm out of brain cells today. There were no asserts in there. Tolas points. Add Tolas 50 points. All right, let's actually see if our test does a thing. Sort. Okay. It does work. It does, work is a strong word. It is acting. It gives me confidence that my sort is going to work properly here. All right, so I want to have a list of bricks equals a new of bricks here. I'm going to make this private. Public tower enumerable of bricks, and we're going to do bricks is going to be equal to bricks, the incoming bricks at bricks dot order. Okay, so we should. This is why I wanted to do the order, because how do I know if it's working? I don't know if I have confidence that this is doing what I want it to do. I'm gonna do this. This is how I want to do it here. We're gonna do sorted brick sorted equals this thing here. All right, I just want to make sure that this actually does what I want. Hang on. Or sorted. Goatmeal and Spurro, welcome back to the stream. How you doing, my friend? I am having a beautiful morning. Goatmeal, how the heck are you? Spurro, how are you doing on this beautiful day? Let's double check that test one more time. Oh boy, it's gonna be a rough one, folks. All right, still, all right, does what I thought it does. It does what we think it does when it do. So now we have our bricks here. Fall is basically going to go through every brick and move it as far down as it can. So we're going to do 4 each. It's going to return an int. All right, so the way this is going to work, I guess I could have written this a little bit better. I'm not liking what I'm doing. Kale bites 3. Kale bites. Let me know if I'm saying that right. Today we've got Kale, bites. Welcome to the academy. Thank you for the follow and welcome aboard. I'm happy you're here, my friend, today. Oh, Kale bites. Welcome to the stream. Kale bites. Happy Friday. Hope you're having a beautiful day. All right, folks. Fall is not quite what I want because it's not. Let me do a thing here. Public static int fall. Given a list of brick. Apply gravity is a good one. Bricks. This will tell us how many bricks actually fell. So I want it to say how many of these bricks actually moved during this fall. Ninja Ola, welcome back to the stream. First vacation day, finished customer project delivery yesterday. Nice. Was a last minute bug and got it fixed and could happily relax there. Congratulations. Welcome to vacation mode. But yeah, this is going to it's going to take these bricks and tell us how many would move and give us back a list of brick new I kind of want this type of thing where it tells us how many it moves, and it's going to give us back a new IEnumerable of if we actually disintegrated it here. Moved. And this is new bricks. It's going to actually move. It's going to give us a new enumerable of the moved bricks. So it's going to move them down. So there's some madness in here that I'm not enjoying. There's some madness I'm not enjoying here. The count doesn't matter, though. You will want to write a second function that's a light version of that, and that just exists after the first block can fall. I think I want this. This will give us back the actual... Oh, because we need to apply... Yeah, you're right. We need to apply gravity here. All right. Fall. This will get us back all our new bricks. Notice I have to produce new bricks because they are immutable, which is okay. Here. And so we need to go, we know that our bricks are sorted, but it doesn't really matter. We're gonna do bricks, dot sort. Let's give us back. All right, so this will actually sort it here. So we're gonna sort our bricks, and then we're gonna say for each brick in bricks. The word brick is looking very weird to me right now. We are going to end up moving the brick down, and then we need to keep track of the positions that are currently occupied. Hash sets, position 3D occupied. Like this. Okay. So we basically need to... How tall? Are any of our bricks like crazy? So the question is, how lazy can I be here? We want to see whether or not they intersect with the bricks below them. And I'm trying to, given a Z index, dictionary int to a hash set of position occupied. Something like this. I could probably do something better than this, but this dictionary here, can't write code at all today, is saying given a Z index, which positions are occupied there. So the idea is, as our brick is, we're gonna move each brick down, and then when it hits a bottom, we say, okay, well, these are the positions that it occupies here in these indices. And so then when we're moving the next brick down, we can say, hey, does this intersect in here? This is so I can avoid writing an overlap. The other option is in my brick, I can write an intersect. Given two bricks, do they intersect? That is another option I can do. That's where new bricks is extra. Occluder, yeah, it's a little bit gnarly here. I'm not sure I like it all that much. We could do yeah, this is a Z index, and which positions are occupied in that Z index. But yeah, so that's sort of what my plan is here. I could write another thing that says, for every brick that has already been placed, check to see if we collide with it, but I want to be a little bit efficient as we're moving down. If this, what is the lowest spot on this brick? is it in a spot? If it can move it down. Otherwise, put it in, like you like solidify it into a position here, and then you add it to this occupied, and you return where that brick landed. All right. So we're gonna say for each brick in here, because the bricks are sorted, we know we are moving the bottom most brick. Okay, so we can shift the bottommost brick down position 3D bottom is going to be equal to bricks of lower, brick dot lower. Just call it lower. I could leave it as another brick too. So the idea though is we're gonna say, well, brick is a brick can fall. This is essentially what I'm gonna say. Well, the brick can fall. So I'm gonna do a true for here. Well, brick can fall. We'll do brick is equal. Oh, can I update brick here? Brick with lower equal to new. So we got to do brick dot lower dot x, brick dot lower dot y, brick dot lower dot z minus 1. And we can't reassign it. All right, so we'll say brick falling equals brick falling. And then I can do falling. This is why I wanted to pull out the lower part. Lower position 3D lower is brick dot lower upper, and then we can just iterate these down together. We'll do lower is equal to lower with z is equal to lower dot z minus 1, and upper is upper z minus 1. So we're gonna move it down. We move it down, and then when we hit the bottom here, we'll do a yield return new brick lower upper. So we have found the new spot of it. Yield return unreachable code detected. Yeah, it's because this here. We'll have to figure this out. And then there's one last thing where we have to like set block in occupied, something like that. Okay, so this is the plan I have in my mind here. Kuani, thank you for that. That's an interesting idea. I don't think it does. Let's try it. I don't think we can do X, Y. Certainly VS Code doesn't think on. Yeah, we can't do a match like that. That would be nice. That would be nice. Yeah, so we have our lower and upper going here. Yeah. So this will be okay. I could also in my position 3D I could do this, which might read better. Public position 3D. Here's the thing. If I do a drop here, what I could do is I could end an N actually. And then this would be a new position 3D. X, Y, Z minus N. I could do this. There's another option. Could do drop in, we drop one. Because technically I could do some optimization where I calculate how far I need to drop initially without dropping it one at a time. You know, so I could do this. It might read letter lower dot drop 1. Upper dot drop 1. And then with that, I could actually do in my brick, I might add a drop in here, public brick drop. Int n is going to a new brick of lower dot drop and upper dot drop n. So if I do this, it might read a little nicer. Brick, brick, falling equals brick. Brick, falling dot drop 1. So we could do that. We could do this. We could, so we could definitely detect some interesting things here where we don't have to drop it one cell at a time if we decide we need to be faster. I could say, okay, well, what's the highest position I've seen so far? And just, I can skip straight to it if I wanted to. All right, but we're gonna say, well, falling dot lower dot z is greater than, 1 is as low as it can go. So, well, it's greater than 1. We move it down. But yeah, so if we're at 1, we can't go any lower than that. We can't go any lower than that. Falling. So we can't go any lower than 1. So if our z is above 1, let me write, and there, we don't intersect with anything in this hash set. So I want to get like all of our like internal positions. So there's a thing I want to do. I'm going to write a helper function here. I'm going to write a helper function that says predicate. So I'm going to have a predicate here. This is going to be of a brick. Intersects here. Collides at. We're going to give an int z. So we have a z index here. And then it's the actual, so this should be a predicate collides at, hang on, there's two things this needs to do. Hang on. I want something that returns a bool. Hang on, bool collides at int z and then a brick to check. Okay. So I want to be able to say, okay, given our lower z, if our falling, we'll start just by saying if collides at. If falling.z is lower than this, and we are not colliding at falling.lower.z on this falling brick here. Duca Soft, welcome back to the stream. Nice to see you, my friend. And Alexa Lauda, welcome to the stream. Happy to have you here. Occluder, maybe something like I numeral that intersects by. I'm going to add in a little thing here. Napalm codes. Good morning, my friend. Welcome back to the stream. It's nice to see all you beautiful people here. We are working on admin of code day 22. I'm running on a few. Look, you're watching the captain struggle today. We're on a struggle bus with the brain power. So we're doing our best. Collides at here, we're gonna say if this brick in this intersection here, so I want to get all of the positions here. This is where like my brain is like I'm struggling hard on this here. We want to say occupied at Z, hash sets of position 3D positions at height. These are the positions we have at this height here. With all our collective bean juice refrigerator, I don't have enough bean juice to wake me up this morning. I only slept a few hours. My watch, here's the crazy thing. My watch says, I was in bed a lot longer than what my watch says, but I was having trouble sleeping. Look at this insanity. Let me go to my dot cam here. My watch tracks my sleep. It says I only slept, here, let's turn it back on. It says I slept 2 hours and 24 minutes. So I didn't sleep great last night. I got in bed much earlier than that, and so I woke up feeling pretty, couldn't fall back asleep, but I'm not feeling great. Greatness attracts greatness, it's true. It's true. It's plenty, carbohydrates, plenty of sleep. Not when it's compounded over a month of advent of code. All right. And then I want like a 2 check. What time do you normally go to bed? I usually go to bed at like 8 or 9 o'clock, 8 or 9 p.m. And I get up at like 3. I've been staying up much later than that because I've had a bunch of obligations this month. What if... All right, so we have the positions that we're there at, and we want to say... can I just get... This is really bad code here. I want to get all of the positions that this brick contains. So I'm going to do a public hash set of position 3D occupied. And we can pre-calculate this. The problem with pre-calculating is when we use these... we create a new one. Oh, good. We are doing a new one. If we didn't do a new here, this wouldn't work. But we're doing it here. Oh, dot cam's on. Thank you, Occluder. Let's turn the dot cam off. I want to do a public hash at occupied. Calc occupied. Lower, upper. And I'll do a position like this. I want to get all the positions that this thing occupies. Saying it needs sleep, I know. It's fell asleep there. All right, public static hash set position 3D occupied. I don't know. I need to call it calc occupied. Occupied. And we're going to do a position 3D up, lower, position 3D upper. And this is going to calculate the positions that are occupied between these two. It's like a triply nested loop, I think. For int x equals lower dot x is less than or equal to upper dot x plus plus. And there's probably a better way I can do this. I could do enumerable dot range lower dot x. I wish I could give it the upper here. Lower dot x to, and then it's upper dot x minus lower dot x plus 1. All right, so this will get us, if we have a 1 to 2, it'll get us 1, 2. The count here, the number of things between the two is like this. So this one becomes y. Can we zip through? Is there a zip? Z. So these are x's, our y's, and our z's. And I want to zip these together. This is where I think the triply nested loop might just look better. let's try something though. We'll try, look, because this is gonna look horrible, I think. Zip. This. No, zip won't work because they don't have the right number of cells in it. All right, we're gonna do a loop. We're gonna just do a loop. For int x is equal to lower dot x. Ridge Raider, I don't know if I said hello as well, but hello, my friend. It says you just got here. Yeah, you did. I did say that you're struggling with brain power with all the bean water. We need more bean water. X is less than or equal to upper dot x, x plus plus. And we want to do this for our y's and z's and y. This is such an error-prone way to do this. This is so dumb, folks. This is super dumb. I should just be writing an intersex here. Let's make this I enumerable. What a mad lad the hustle Capcoder has is unstoppable. I don't know if hustle is the word I would use to describe it. Yield return, new position 3D, X, Y, and Z. And I don't know why these keep wanting to capitalize. Oh, it's because there's an X, Y, and Z up here. All right, let's make sure. Okay, I think this will do it, and then we do this here to turn into a hash set. Smab, I don't know. I am dragging hard. Oh goodness. Apila, thank you so much for saving me points. Add Apila. We're never getting out of here, man. We're never gonna solve this puzzle. I keep having too many mistakes. Smab, I really should have written an intersex thing here. This is dumb. But we're going with the insanity here. We're going with the insanity here. So we have occupied here, and then we're gonna have our collides at to check dot occupied. I'm making the terrible. My code is so bad. Occupied. My hope is we don't have any insane occupied. Occupied? Oh, is it a property? It's a property. Okay. So we can do, all right, I can do to check dot occupied dot intersects positions at height. And shouldn't this return a thing here? Alka! Alka, 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 thank you for the raid today. How are you? Alka, Alka, how was your stream? How did you fare today? Alka, were you working on the admin of code? Welcome to the stream, my friend. Enjoy your, no worries. I know how it be. I know how it do. Enjoy. Thank you so much for the raid. Have a beautiful day. Don't forget to keep coding. Keep growing, be the best you can be, and you're welcome back anytime. Alka, folks, be sure to give Alka a follow. Give him some love, hit that little heart. Alka is on our leaderboard, I believe, but have a beautiful day. We'll catch you soon. You probably need ... there. I actually don't even need it to be a hash set. Really, I want to do... I want to know if there are any things in this. If there are any things in this intersection, I basically want to do a count. I want an is empty on it, right? Basically, if count greater than 0. This is what I want, but I don't want... I want it to be. I want a simple thing here that it will end soon. Can I just do any? Can I do this? Will any true return false if it's empty, or is it just any? Ah, beautiful, beautiful. That's exactly what I want. Will any return false if it's empty? Is a question that I have. C# REPL. Let's test it out. Let's check. Let's test. Var x is equal to int array 0. Urpatacha. Why can't I do anything correct today? Equals new int 0. There we go. X dot any. False. It returns false if it's empty. And true if it's not. Okay, so we get false if it's empty. All right. Uma Paracha, welcome back to the stream. I hope you're having a beautiful day, folks. If you didn't know this, if you didn't know, Captain Coder is me is Captain Coder, and me, Captain Coder, is a computer science educator. I teach computer science and programming at a school for ages 10 to 14. It's my full-time job. I absolutely love it, but I do teach lessons if you or someone you know is interested in learning about programming, learning about data structure and algorithms, learning about game dev. I'm not that great at game dev, or development in general. Feel free to head over to Ko-Fi. You can purchase some lessons, individual or group. Is null or empty? Doesn't work on an IEnumerable. It should return true because that's the identity element for the logical operator. CLBI, I'm doing all right. I'm running. I have no brain cells today. I mixed up all and any. All, yeah. So any here, I think, is what we want here. And I can. There's one little thing here that's not right. Occupied could be empty. So we're gonna do get value or default of z, comma, can I just do this? Empty. Okay. I showed on stream. My watch says I only slept for 3 hours. All uses the operator, I think. Did you finish yesterday's puzzle on C64? That's a good question. Broadbringer, thank you for following me today, Broadbringer. Did you bring the broad today? Welcome to the stream. I hope you enjoy your stay. Welcome to the stream. Thank you for following me. Broadbringer, hello. Happy Wednesday. Happy Friday. I hope you're having a beautiful day. Happy December 22nd.
No.
Happy to have you here. We are losing our minds. We are losing our minds here.
You were in the back. Pay attention.
All right, so we're saying falling is greater than 1, and we're not colliding at the lower position. Oh, hang on. Okay. What's interesting here, I have something wrong. We're gonna keep falling we're gonna fall until we hit something. Hang on. We need to move this. All right, so this needs to be greater than 0. For the following reason. When we hit something, we're gonna move the block back up 1 position. When we hit something, we move the block back up 1 position. Okay. So when we hit something, we move the block back up because we're saying keep going until we collide. All right. So I need a lift. I need a lift command. Public block lift. I could also say previous. Okay. All right. So I could also do like previous block. Let's be dumb. All right, we're gonna be dumb. This is gonna be the slowest program. This is gonna be awful. Part 2, I'm gonna have to start over from scratch, or maybe I'll just leave it running. Oh, Kawani, you're brilliant. Did you write the code for Unity or clean C#? Broadbringer, I was thinking, I should have done this in Unity. I wouldn't call it clean C#, but it is just plain C#. Certainly not calling it clean. Kuwani, you're brilliant. And this should actually be falling equals. Oh my goodness. None of this is gonna work. Falling equals falling dot drop -1. So we're gonna move it up 1. And then we yield this one, and then we have to do a thing called set block. All right, we're gonna do a void set block, brick block, set brick. Apparently I can't. Set brick. Okay. So we are gonna do for each. I can't quite do it for each because I've defined this in a really interesting and dumb way. Position 3D in position in blocks dot occupied. So these are the positions that it occupies. Let's rename this as to set. And we are going to go through all of these positions. And we're going to say occupied. If someone end me, please. This is get value of position dot z out hash sets of position 3D. This is gonna be our, oh my goodness, I'm losing my mind. In Z. All right, and we're gonna say that if we don't have it, in Z is gonna be equal to a new hash set. We're gonna add it into our occupied here of Z is equal in Z, and then position dot Z lowercase p. There's got to be so many bugs. I've not run anything. This code is going to be so broken. It's not going to be good. And we're going to add this position here. Okay. Oh my goodness. Oh, this is bad. At least I'm honest that this code is horrible. All right. So then we call set brick falling. Boom. Okay. Let's move these down here. This is some of the worst code I think I've ever written. Even worse than yesterday. I thought it couldn't get any worse than yesterday's code, but yet here we are. Here we are writing some really gnarly code. It's not even 7 a.m. Not even 7 a.m., folks. So you're saying Dukasoft, exactly. If it ain't broke, look, you've seen me write worse. It's true, I have written worse. Look, Kuwani, I should have gone with a mathy approach rather than this iterative approach. I'm not even close. I need to now. All right, let's write a little sanity check here. But yeah, let's write a little sanity check that will test out public today's math-wise. Today's there's not enough math. I feel like I could have done write a real intersection and stuff on this, but I'm looking at my inputs going none of these are crazy, right? None of our bricks are like soup. Look, all of our X and Y's are within 10. Our Z's there's no sanity clause. It's true. I'm losing my mind. All right, let's do a sanity. Look, let's add a sanity clause here. Fact. Public void test fall. We're gonna start with these bricks. Do I assume they're sorted? No, I sort them. Okay. We're coming here. We'll do these bricks here. Call this a list of brick. All right. And then we're going to do bricks, a tower dot fall bricks. Okay. And this is going to get us back. Let's go ahead and turn this into an array. And so we should have a brick array tower here. And this should be our input here. Do we have what they should be after they all fall? It doesn't really tell us what they should be after they all fall. They kind of show us. They kind of show us. I have very dry code this morning. Look, my code is horrible. But I want it to be Smab. I want it to be in this format so that it's easier for me. I don't want it to have to draw it out. I suppose. All right, I suppose I could write a pretty printer for a tower. Should we write a tower printer? Should we get crazy and write a tower printer? That sounds like a bad idea. It does tell you in a diagram. Okay. Y, X. Oh, this is after it's fallen. X and Y and Z, and then there's multiples here. All right, so I kind of just want to print the bricks out and see what they look like here. Maybe we could write a little program to sanity check here. Can I? All right, let's put a debug console power dot assert dot true. I just want this to stop here so I can look at my. I want to look at the state of this thing after it has executed fall. Maybe I should just step through fall. Who knows? Test fall. Let's do a debug here. I want to eyeball it. Want to eyeball the madness. .NET. Okay, there it goes. Close that. All right. My tower here. Let's make sure this is sort of. I wish these printed out a little bit nicer. So this one should be the lowest. I have to give them labels to be able to see this here. Hang on. I'm going to change my printer on this. Brick. Public override. String to string. And we're going to make this be lower.x lower.y lower.z upper.x upper.y upper.z. Tuber Tugger said, oh, Tugnik Quadrant says, Tuber Tugger. I don't know if I said welcome back to Tuber Tugger Toak. Welcome to the stream. Welcome back. We're losing our minds over here, so I hope you don't mind watching my descent into madness.
In the back. Pay attention.
Thank you for the pay attention. These are getting hard, man. I don't know if these are getting hard or if I'm just losing my mind. One of those two things is happening. Okay. Debugger display attribute. Debugger display. I don't know what that is. Aging years in 25 days. I have some gray beard hairs this morning. I actually found some gray beard hairs. Like, oh no, I gotta stop coding, man. debugger display. How does that work? Tell the debugger what to show using the debugger display. Debugger display. Ooh, interesting. To the class in record. Oh, this looks really cool. This looks really cool. Debugger display. And it knows, do I have to put it just knows that this should be an attribute lower.x, lower, here, we're gonna try this. This is cool. Smab, thank you for showing me this. We're gonna find out. Lower.y, lower.z. So I would do something like this. We're just gonna take a look here. If I was doing this in Unity, I could just eyeball it. I could physically move around in 3 dimensions. Nice, it does. It does, very cool. That's awesome. Okay. Upper.x, upper.y, upper.z. Very, very nice little attribute here. You could probably do lower than in the position do, I could do, maybe I could do something like that. I don't know. I'm okay with this. Okay, let's take a look. Just try and sanity check. I don't know if I can actually sanity check this all the way. Tolus, we could probably do that. Messut Derms. Messut Derms. How are you doing today? I'm great, cuz Messut Derms. Click that follow button for me. Thank you so much for the follow, Messut Derms. Welcome to the Captain Coders Academy. Hope you have a beautiful day. All right. Let's take a look here. 101 121. This is our bottommost one. Makes sense. I should be coming back in that order. Let me pull I'm gonna pull these 2 things in here. Boop. Don't like that. That seems okay. Just sanity check here. This is our Y. We have a... Honestly, I can't even tell. The eyeballing it here says I have 1, 2, 2. So I should have 2 things on row 2. 3, 3, I have 2 things on row 3. I have 1 thing on row 4. I have 1 thing on row 5 and then a 6 on here. So like my brain is telling me that I think we got it close. But it's really still difficult to eyeball here with this. We're just gonna pray, folks. We're gonna do hope-driven development here and just assume we just got I'm just gonna hope it worked. All right, I'm gonna hope it works. If it fails, oh well. Okay, so we're gonna assume this fall command does a thing that I care about. All right, now, compared it to mine, it's the same. Smab, you're the best, my friend. Thank you so much for comparing it here. Help give me some confidence that it's working. Okay, so now I want to disintegrate each brick and say what's the result of disintegrating here. So basically we're saying figure out how the blocks will settle based on the snap. Once they've settled, consider disintegrating a single brick. How many bricks could be safely chosen as the one to be disintegrated? All right. So I kind of want something like this: public static int check disintegrate. This is where if I just built up a graph of what was touching what, we'd be fine. We'd be okay. I could still kind of do it. I could still, like, this is set up. I'm like checking every position and stuff. Like, how hard would it be for me to build a dependency graph here? How hard would it be for me to build a dependency graph here? Because collides at, instead of returning a bool, I could return the brick that it's touching, and instead, so I'm already doing an intersection. I could actually just return all the bricks it's touching, and what I could say is I'd have to have it go in both ways. So when this thing's coming down, there needs to be some information stored in a brick saying these are the things that you're supporting, and if something has two supports, it doesn't matter. It doesn't matter. Let's do the dumb thing. We're gonna do the dumb thing though. Public static int check disintegrate. It wouldn't be Captain Coder if we didn't do the dumb thing first. It's like, do I really want to logic my way through this? I'm gonna need it for part 2, I'm pretty sure. If we disintegrate a brick, hang on, we have a teach what not to do. Cap, have you considered doing a flood fill? I'm still on part 1, Spoof. I don't know what a flood fill would help with here. In this case, so the flood fill. Have I considered a flood fill? No, I haven't considered a flood fill. I was gonna do. I normally stay with the dumb thing. Because I tried flood fill on day 18. Gotcha. Look, flood fill. Look. If you have a problem and you can't figure it out, you can probably solve it with a flood fill of some sort. Breadth first search really is a reduction. Everything reduces to a breadth first traversal. If flood fill doesn't help, how about LCM? It's true. Just throw an LCM at it. Let's try that. Mathutils.lcm on our bricks. Let's see if this gets us the correct answer here. Let's see. So we have a list of brick coming in, bricks. We got a compiler here, lowercase b. All right. And then we can just cast this to an enumerable of longs. And then we just need to, okay. So we need to make it, all right. So let's do a public static enumerable of longs to LCMable. We're going to take in an arbitrary object, obj. So given an arbitrary object, we're going to get back an enumerable of longs here. All right, so we're going to do 2 LCMable of our bricks. Hang on. Cannot convert long to int. Okay, we need to return a long here. And so now for this object, we can do object dot get hash code. Okay, get the hash code of it, and then turn that to a string, and then we're gonna do a select long dot parse. So we have a ch dot toString. Oh my god, we've solved all of it. We've solved all of these. Perfect. Perfect. Look, every problem in AOC can be solved by just converting it to an LCM. An LCM here. All right, let's test it. Let's test it here. Day 22. Let's put this in part 1. Part 1. So we are going to get a list of bricks here. This is brick dot parse all inputs. Let's give us an enumerable, and then we can do 2 LCM 2 hang on. It was what did we call this down here? Check disintegrate. Okay, and then we do check disintegrate tower dot check disintegrate bricks dot parse all input dot check disintegrate needs to take a list, so we got to turn this into a list. All right, let's test it, folks. Hold on to your butts. Hold on to your butts. Let's see if we got it. Let's see if we got it. Here we go. See if we have an infinite loop. Dang. That broke everything. Do we have... I don't understand how that broke everything. That is kind of crazy to me. All right. 100... Nope. Didn't work. Didn't work. All right. Let's take it back. Topologist, good question. I can go over that in just a minute. I broke all of this stuff somehow by adding in... What did I do that... Oh no. Why does my sort fail now? Did adding this in somehow make these things fail? Parse all. Something terrible has happened. When did my test start failing? Oh, it's probably because I do this and it does a full... this actually is modifying this somehow. What is going on here? Parse all input. Did I adjust? Did I change my sample input somehow? I'm so not happy right now. Parse all. If I run it independently, does this work? What? Why does everything hate me right now? This makes no sense to me. Run this debug here. Topologist, I kind of ended up solving yesterday by hand. Let me try and fix this. This is crazy. This is crazy. Bricks. 101121 002202 023223 004 024 205 225 016 216 118 119. This is correct. Why is the subset no longer working? Did something I've done cause... Oh, it's this. I added in this occupied, which makes them not comparable anymore. Private occupied. public I have a property here that, so records do this thing where they, all right. So I did, that's essentially what I did. I found an insane, what is going on? Can I not do this? Can I really not just pre-compute this? It includes private properties. So I wrote a bunch of code so I could find the pattern, and then I didn't write a code. The code doesn't solve the pattern for us. You could have used order by outside of the brick. Yeah. So Smab, what's happening here is, I believe this is causing my equality check to fail. I just want to understand where my issue is. The Gypster, I might do that. I just want to understand why the equality is no longer working. I didn't think it used private properties here. Okay. Yeah, apparently, and I didn't know this, apparently, it will use private fields in the equality check. I wish there's a way that you could have it ignore that. All right, so we're gonna see if we're fast enough here. I hate this. All right, this is incredibly terrible inefficiency here. Terribly inefficient. Okay, so now that I got there, topologist, I'll show you my solution for day 21. I don't have a program that runs on an input. I don't have a program that runs on an input. So this is where what I ended up with, and I calculated it for the sample input and the puzzle input as well. So I ended up writing a program that I could generate these ASCII pictures like this. So this is saying generate with a radius of 9. This is a radius of 4, I think. So from the center, I got 1, 2, 3, 4. So this has a radius of 4 in each direction. And so I could eyeball, I was going like, okay, well, I see that these, there's a checkerboard pattern that repeats here. And I did this with my big output too. I just don't have it anymore. And I wrote code that could pull out a single, given a row and a column inside of the grand grid, I could pull that out. So if I said 0, 0, it would get me the top left corner here. If I said like 5, 5, my radius was 5 and I gave 5, 5, it would get me about the center panel here. And I wrote code. Let's see, do I have puzzle 5? Here's a giant one. So here's on my actual input. I did a 5x5, this one. So this is like my actual input here. And when you zoom out, you can see this one you can't see because it went too far. but I wrote a program so I could examine this, and we have like this tile, you can sort of think of a checkered pattern of white and black. A and B is what I did in my mind here. So we had like an A and B for it. And then I calculated the number of different patterns we saw. So I could say, okay, well, every grid, I could hash that grid into a dictionary and say, or into a set and say, do we have that pattern? How many times do we have it? And in our global grid, what positions have that pattern? And I said, it turns out if we have a radius that was even, we had 14 patterns. If we had a radius that was odd, we had 13 patterns. This is for my inputs. In the sample input, it was like 18 and 19 were the patterns for the sample input. Using this information, I wrote a program that output this code here. Here, let me take this. I'll put this into a new file. It output the growth rate. So I ran the expansion. I ran it on a couple of different radiuses. All right, let me get rid of these radius lines. Let me zoom in here so you can see. So I ran it here, labeling each pattern. So I labeled each pattern. And so there's 14 patterns here. And I've grouped them by their growth rate. All right. So for a rate, let me see if I can line these up a little bit. But we have, for a radius of 4, these 4 patterns occur 3 times, 5 times, 7 times, 9 times, 11 times, 13 times. So as our radius increases, then we have 1 minus our radius occurrences, and there's 919 919 spaces in this pattern I can reach, 930 in this one, 940 in this one, 933 in this one. So this one occurs 4 times. This is on the outside of the diamond. This is on the outside of the diamond. One of these is top left, one of them is top right, one of them is bottom left, one of them is bottom right. These are the top right, bottom, and middle. This is the top right, bottom, and middle here. So this is where the diamond sort of comes together at the top right, bottom, and middle. This is, again, there's these alternating patterns around the grid, and this is the alternating pattern. And then this is the internal pattern. So this is the checker pattern A and B, and it grows squared. So it's 3 squared, 5 squared, 7 squared, 9 squared, 2 squared, and then this one's 2 squared, 4 squared, 6 squared, 8 squared, all the way up. And so I ended up using that information to just calculate the answer by hand, saying, well, elf radius, I calculate my elf radius, which happened to be even. So I know that it's going to grow with this size here. So I just calculated it by hand, summed it up. I could write a program, and I was planning to write a program, but I had a bug here where my elf radius, I was using an int here and a long down here, and I spent 2 hours thinking I had my calculation wrong before realizing these were I had an overflow with my integer when I was doing this calculation. So it took me a really long time to realize I have that. I spent like 2 hours doing it. For every possible count, if I understood right, almost. So if I moved this code up to the top, it could do it. If I move this code up to the top, all I have to do is calculate one with a radius of 4, and then I have the solution. So it only works for the input that is written with input. So there's some special properties. It will only work for the special property of this input. Calculating the radius is interesting. So there's a special property with my input and all of the inputs where the row we're in is empty. The row we start in is empty, and the column we start in is empty. So it allows this radius for the repeating pattern to be easily calculated. With our sample input, the radius was a little bit different. Every grid size, many steps, and then there's a simple quadratic function predicting the count so you can get the answer instantly. Yeah, so I ended up doing this by hand. I haven't looked at any other solutions. I was exhausted when I did this last night. I thought it was going to take me much less time to do this, but the debugging that issue was a pain. But yeah, this was my day 21 solution. It works. I could do this for any input, but detecting this pattern for the sample input is different than detecting it for the puzzle input. So the sample input ends up, I don't know if I have a good example of it, 9x9. Yeah, so the sample input is interesting because you end up with these three, you end up with, instead of 14, at the top end, you have these unique groups of 3 or 2, depending on whether your radius is odd or even. The puzzle input was designed has a very specific quality where you end up with just 1 at the top, right, bottom, and left. This one, you end up with 3 at the top, 3 at the bottom, 3 at the bottom. On the right, you end up, 3, yeah. So you end up with a bunch of different patterns there. And so it's just trickier on the sample input. Super fun puzzle. I really enjoyed it. I hated that I had an integer overflow error. I had an off by 32 bits error, which was really frustrating because I thought I had a long. I kept going like, it's a long, this is crazy. And I did some stuff that ended up being negative, and that's something I did something that made it negative. I was like, wait, it was like a negative, like it when it really shouldn't have. Anyway, okay, so I believe I have my fall stuff working here. I need to actually do a disintegrate. So the disintegrate I wrote is clearly not correct. Clearly not correct. Went off on a little bit of a tangent here. We need to do something like the following. For kind of want to not modify the original S. Bricks equals bricks.order. I'm gonna make a copy of this here. Correct, Code Monk, off by 2 to the 32. It's classic. So close. So close. To check disintegrate, I want to say for every brick, brick in bricks, if I were to remove this brick, would anything fall? Is kind of the question I have. So I almost want to do this for, and then you can just do that for the above, everything above as well. Does anything topple if I remove a brick? I kind of want to say for, but like my bottom. All right, can I do a thing here? It says int bottom. Why is this so difficult for me to conceptualize here right now? I need to say for every brick, if I remove that brick, and then call, essentially I want to say if I remove the brick and call fall again, do my bricks fall? Or do they stay the same? Can I simulate a fall? For each brick in bricks. I'm gonna remove the brick here. This is like one of the most crazy inefficient things I could do. Where I want to so I want to do for int ix equals 0, ix is less than bricks dot length count ix plus plus. Brick removed is equal to bricks at ix. For int jx is equal to ix plus 1, jx less than bricks dot count jx plus plus. If I remove this brick, are any of the bricks above affected? Right? So I want to do a thing. I want to, so I often tell my students, wouldn't it, you know, when you're writing code, ask the question, wouldn't it be cool if int count is 0, return count? Wouldn't it be cool if a method exists called, you know, is stable with brick removed? And so we have brick to check is going to be bricks of jx. I want to say, is to check stable with this brick removed, right? And so if I create a local function here, bool is stable with brick removed, brick, sorry, this would be to check removed, like this. Man, if it works in English, it has to work. And then you say, okay, if this method doesn't exist, go ahead and write it. So now is stable with brick removed. And we're gonna say if we are not stable with this brick removed, return count plus plus. Okay. So this is if I could just write this method, we'd be good to go. All right. So here's the interesting thing. I still have to check. I kind of want this thing. If I have this thing, I can just basically say, is there something, if I move myself down, can I move down? This is why I kind of want to just call fall again on a brick. I want to be able to do this. Given my brick, can I drop 1? Right? Can I drop 1? Let me build up this thing again. I could also just pass this in. All right, hang on. What if I take this in tower? What if I take this thing in here? So I have my bricks. Is stable with brick removed. Oh, you're right, Smab. You are correct. I was thinking which ones make things fall. So it's stable with brick removed. Okay. So I want to get my removed occupied. To check dot drop 1. All right, it says in a brick if moved. We move it down 1. We want to go through each of the positions. We need to remove the brick from here. We want to remove with but not actually remove it from here. So we're gonna say, all right, to check if we drop it, we say for each position 3D pause in if moved dot occupied. So now we have all the positions of this one that it moved down. We need to go through the ones in here, right? So we're gonna say tower of position, get value or default position.z, or give us an empty hash set. Okay, so this is our hash set. I want to make a copy of it. We're getting insane. Look, my garbage collector, we're flexing the garbage collector today. Hash set position 3D. This is horrible. Occupied. In Z position here. All right. We get this here. I want to make a copy of it. We're going to make a copy. We're doing 2 hash sets to go and make a copy so that I can do in Z position dot remove range. Is it remove range? I want to remove remove dot occupied. Dot. What would it be? What I want intersects. I want to remove the intersection. What is it called when you cut a chunk of a set out? Union. We have. I want to do like minus removed dot occupied. What is this function called here in set logic? Set remove set. What is it called? Isn't there like C# set hash set? Isn't there a class? Except. Thank you. Except removed. Except with. Oh, this is. I want. Isn't there a union? I don't want union. I want except with. Set subtraction. Why doesn't except? Except with remove.occupied. Okay, perfect. And it modifies it. Here. And then we're gonna say except with removes all the elements in the specified collection from the current hash set. All right, so in Z position here now, we want to say if any of these positions intersect, then we can't fall. Okay, so we're going to say if in Z position dot contains position, return false. All right, this felt really painful. Hang on. If it contains it, we return true because we can't go down. Mendoza, welcome to the stream. How the heck have you been, buddy? I hope you've been having a beautiful, beautiful December. I'm glad to see your name in the chat. Oh my goodness, this is insanity. If Z contains this position, that means we can't move down, so we return true. We don't actually remove it from anything, because we make a copy. Art, welcome back to the stream. Welcome back to Captain Coder Captain Coder has not slept, and Captain Coder has 7 brain cells. 7 brain cells. Look, maybe I got more than 7 brain cells. We might be okay here. So I want to get back. I need to get this dictionary of occupied things back. So I'm going to make my tower. man. You think I'm overcounting? I've slept like 3 hours. I've only slept like 3 hours. What makes you think I am overcounting, Smab? Because things can move into the ground, I think is what you're saying. So if we have two things at the bottommost position, they can move into the ground. Oh, you're overcounting the number of brain cells. I am overcounting here too. Is stable is also incorrect because we need to make sure. We're gonna say if moved dot lower dot z. If we've moved it and is less than, so we want to say if we're in the ground, we're stable. So this means we were touching the ground here. I don't have too much to do the rest of the day. I'm on vacation finally. It's been a grueling couple of days. It's been a grueling month. Advent of Code's been killing me. In a fun way. How the heck have you been, Art? That said, I tried to sleep. My watch just, I feel like I woke up really tired. My watch tracks my sleep. But my watch says I only slept 2 hours and 24 minutes. I was certainly in bed a lot longer than that. But apparently I was not sleeping well. Apparently. So that's just a little bit disappointing. And then I woke up. I woke up and couldn't fall back asleep. And then I was like, all right, let's just do this thing. Yeah, for less than or equal to 0, that means we're in the ground. We're already touching the ground. My watch says 2 hours and 48 minutes sleep. Oh, Smab, we gotta sleep better. Okay. I've been very busy with schoolwork this week. Nearly done now. Just waiting for some feedback where we can deliver our final report for the holidays. Awesome. Somehow today's well did not feel really rewarding. Just exhausting to implement the update rules, but no real brain teaser. Yesterday was a total brain teaser. It was super fun. I'm glad you got some sleep. Let's get some sleep, Art. Folks. Attention all lurkers. If you don't know the incredible Art Berkless, he's the creator of Warlock's Gauntlet. Check it out. Not only is he the creator of Warlock's Gauntlet, he's creator of the engine which runs Warlock's Gauntlet, a swords and sorcery themed hack and slash inspired by the classics Doom, Hex, and Heretic. You know you're going to love it. If you want a game that is challenging, fun, and beautiful pixel art, be sure to give it a wish list over on Steam, and be sure to follow Art where you can watch him learn and program in C++. Art is learning C++. He's gotten quite good at it. Nice spoof. Congratulations on part 2. But yeah, folks, be sure to check out Art Berkless. We love Art. Incredible streamer. You got it under 1 millisecond. Nice. Nice. Okay. This is going to be horrible here. I need to get back. I'm just going to change my fall here to return bricks and this hash, this thing here. Which is terrible, but oh well. List brick bricks. New bricks. And this is, instead of yield return, this becomes new bricks dot add this, and then at the end of the day we return new bricks and occupied. Okay, so we should get back the two things we need to call it check disintegrate. Sticky cub. Welcome to my stream. Oh yeah, I want to say thank you to a sticky cub. Sticky cub, thank you for following me. Sticky cub, thank you so much for the follow. Happy Happy, what's the day? Happy day to you, my friend. Happy Friday. I keep wanting to say happy Wednesday. My brain can't figure it out. So tower dot fall here. We got to give it a... Wait, why does fall... Oh, it takes in a list of bricks to fall. So then we're going to do brick, not parse all, input. Dot. There we go. And we're going to get back our list of bricks, dictionary. This is horrible. I'm so unhappy with the code I've written today. You guys should all be very, I hope you guys are just as ashamed as I am. Cody, give us happy day person. Yeah, sticky club, sticky cub. I want to say sticky club, sticky cub. All right, so now that I have these, I can do tower dot check disintegrate bricks tower. And we've written, there's no way this is gonna work on the first try here. I keep having all these little typos, all these little things. People in the chat keep saving me from myself, but there's no way this works. But we're gonna give it a try. It doesn't even compile. I'm imagining this doesn't even compile. .NET build. I'm guessing it doesn't even compile. It does compile. It compiles, but these don't run. .NET build? What? .NET test. We pass, which is insane to me. These don't say they passed. Let's test on our puzzle input. Puzzle input. Public static read only string puzzle input equals file dot read all text input.txt. Line 36. Oh, there it is. What? Where did this even come from? Dot should be subset of. Okay. Yeah, this isn't. What is going on? Oh, I'm on the wrong day. I'm in the wrong day. .NET build. Okay. This is blowing my mind here. All right, line 95. Let's just get rid of this thing. Okay. Now we should fail some tests. There's no way I got the test right. Now we probably have an infinite loop on my my puzzle. Okay, we failed. I got 19 for my sample input, which is clearly incorrect. The good news is that it didn't take that long to run on the puzzle input. That's the good news. That's the good news here. Let's make sure this runs here. Science, welcome back to the stream. Happy Friday. How are you doing, Balint? It's nice to see you, my friend. Okay. No infinite loop. Oh, man. And the dev we're sneaking up on Chris. I know, it's crazy. It's crazy. The holidays are coming. The holidays are coming, folks. If you guys don't know, we got two incredible people here. We gotta give a shout out to both of them. Science first. Science, incredible streamer, incredible human extraordinaire, educator, studies the ants. You're incredible. I can't get enough of Science. Be sure to go check out Science. We love Science. Be sure to click that heart. And the dev dad is incredible too. They're both amazing human beings. We love them both. I don't even know where to start with my debugging, if I'm being completely honest. Let's try. Let's make. Let's do it. We'll start with checking disintegrate. Let's start with check disintegrate here. Whoa. Yeah, it's thank you for the Dev Dad. Thank you for the whoa, Dev Dad. It's so nice to have you guys here. Let's see if our disintegrate. I feel pretty confident our fall is working. I did make some weird changes to it just a moment ago. That could be causing problems. We also haven't taken a break yet today. You know what, folks? We're gonna take a break first. All right. We didn't get it right on the first try. We're gonna take a break. I need some more bean water. I need some more fresh water. Can I give a shout out to the Dev Dad yet? Let's check out. Shout out the Dev Dad. I gotta wait 40. We're gonna take a break here in 41 seconds. I'm gonna stall. Here. Let's see if I go to debug this test here. We should hopefully stop right here. Yeah, Dev Dad, how the heck was your stream this morning? I was there. I was lurking a bit. I'm having trouble sleeping. My sleep was not good. I'm running on fumes a bit. All right, tower 0, 1, 2, 3, 4, 5. This already looks wrong to me. This tower already looks wrong because in our puzzle, I think we go up to 6. This is the wrong thing. All right. So our fall might actually be broken. Where is my web browser? There you are. Yeah, we should go up to 6. But my key, 1, 2, 3, 4, 5, 6. Never mind. We do go up to 6 here. So the tower looks, at a glance, is looking okay-ish. For and then break. There we go. We need to go to the. I know that this might be it. We're counting how this is saying how many bricks. How this was counting like how many things were stable. All right, let's try that again. I needed a break here for sure. Still broken. Still incorrect. Closer. Off by 1? Off by 1, perhaps? Could I just subtract 1 and get the right answer? Off by 1, perhaps? Probably not. Is it because the last brick can always be safely removed? I think I don't think we're gonna pass this test. It's not gonna pass. All right, this would be insane if it works. It's not an off by 1 error. There's no way it's an off by 1 error here. Let's see. What did this say? Let's try it. Let's try this number. This can't be right. Yeah. I didn't think it was right. This felt very. Very wrong there. I know, Spam. I was like, there's no way this is an off by 1 error. I don't actually want to do the count here. I want to do, hang on. Am I even solving the right question? 5 bricks can be safely disintegrated. How many bricks could be safely chosen as one to be disintegrated? Let's start. Count looks false. You just want to check if it's safe to remove. Yeah. I just want to check if it's safe to remove. So I'm going to do... My count here should start at my bricks count. So we say this is the number of bricks that's safe to remove. All right. We're going to go ahead and remove we're going to say remove this brick. If it's stable with this brick removed, for every other brick, if it's not stable, we have to add it back in. I don't know why I can't think. I think we got one. We got one. Oh, now it's counting. Hang on. I can't think. All right, this is how many we can safely remove. This is how many we can safely remove. Okay. If it's not stable, then let's just keep shotgunning this. Let's just keep shotgunning this. Hang on. We're going to start by saying we can remove every brick safely. All right, we can safely remove every brick. So we go ahead and remove it. And then we say, okay, if we couldn't save this one doesn't count as the ones that we can safely remove. Yeah? All right, shotgun. Come on. Give us a 5. Go. 6. We're off by 1 again. I think I did the exact opposite. -1. -1, right? -1. That's all I have to do here. I'm pretty sure I have the exact same. I'm gonna lose my mind, folks. We're going crazy here. This. All right, we got a different number. Let's try a different number. No. All right. Hang on. We can think this through. I don't know why the second loop just goes from JX to +1. It should check all blocks or not. That's a good question. They should be ordered from the bottom up. All right, let's try. You have an excellent point here. For each brick to check in bricks, if to check is equal to removed, skip it. They're ordered ascending, so I feel like that should work. I didn't want to do that. Where's my test? But it could be. We still fail. I think because they are ordered correctly. I guess I don't think I actually need to check anything below. All right, folks, let's give a shout out to the dev dad. Dev dad. There we go. Dev dad, incredible streamer, father, software engineer, creating a product we called Embedder, coming out in January. Be sure to give him some love. Click that follow button, folks. We got to take a break. My brain can't handle this right now. So hang tight. Everybody. We'll be back. I'm gonna get myself a little bit. I just need a quick brain break. Ramble. We'll be back. Hang tight. Don't go anywhere. The captain shall return. All right, folks, Captain Coder's back. The rare seated Captain Coder. I'm tired, folks. I'm hoping to get through this part one. We're going to read part two afterwards, hopefully. Well, if we can get through it. I don't have any more caffeine because I'm hoping I can just go to sleep after the stream, but I do have myself some nice tea here. Decaf. No caffeine in this tea. Maybe I should have done decaf coffee. But I'm sure that there must be a bug in this. Clearly, there's a bug in our logic. I'm going to use the debugger and hopefully be able to find where we've made where it all went wrong. Well, you see, about 35 years ago, in a hospital somewhere in the United States, the captain was born, and it was all downhill from there, folks. It was all downhill from there. Oh, what a pretty little ladybug. All right. Count is 7. And we're gonna say, I'm gonna put a breakpoint here. I really think that this can be, I truly believe that this is okay. It checks all the bricks that are above this one. I truly believe that this is okay. That we can say start at the one above this. It's sorted low to high. So if we remove this brick, anything above it. Am I doing this backwards? No, I say remove this brick. This is the lowest brick here. And then check all the bricks above it. Remove this brick. And then check all the bricks above it. If any of the bricks above this one end up moving down, we're sad. Okay. Then we can't count this brick and we add it. If it is not stable with this brick removed, remove the count, we break and go up. We go to the next one. Okay. That's the logic. Let's debug it. Oh, let's take a sip of our leaf juice. Oh, some nice chamomile. Continue. Removed. All right, so I thought, okay, here it is. Removed has a nice syntax here. 1 0 1 1 2 1. Continue, step over. Is this brick on top of that brick? 002 202. Let's step into this here. Really, this is the best spot to stop. So we can step in and say to check and removed. So to check, we're gonna drop it by 1. So we now have the Y position down at 1. And we're gonna say for every position in this thing, get back the occupied. So position 001. So that's the first position, 001. Our tower here in this Z position. The bottom most row of our tower minus, so we removed everything from that position, from that row. So it shouldn't be there yet. The next position, I don't know if this is helping me at all. My brain, I don't know if my brain can handle this. I might need to physically build this with Legos or something. Because I can't think. We might need to fail part 1 today and just go to sleep. We might need to just we might need to bust out the Legos here and build this thing. Because I can't, this is not helping me. I could draw it out here. Let me maybe try drawing this out here. I have trying to turn my remarkable on here. All right, let me draw out. It's hard to conceptualize or to visualize this thing here. Lego may be too stable. 3D image of the example. Mizzard, thank you. Thank you. Okay. Okay, Mizzard, that's great. Mizzard, thank you so much for this. Mizzard, I appreciate that. This could be really helpful. So, this one here. So, this one should, if we remove this, is stable. We should end up with a true here. Okay, so if we remove... No, we should end up with a false. It should not be stable. All right, so that's something I can do here. Let's do a step return. Step return here should be not safe to remove. All right, so there's clearly a bug here. Oh no, if it is not stable, we reduce it. So we're removing this brick here. Terrible, terrible, Alka. It's going terrible. I cannot think at all here. All right, so too many negatives to make it easy to understand. Yeah, my code is so horrible here. Alchem, I'm so tired. I cannot think my way out of this box here, and it's been rough. It's been rough. I think I want to just rewrite this is stable with brick removed, or check disintegrate. I can't think, and I'm running on a few hours of sleep, and I'm getting close to just saying I need to take a nap here and go to sleep. Fires, thank you so much for the follow. Fires, thank you for following me. Fires, thank you. I can't even sing. Thank you for the follow, Fires. Happy Friday. Welcome aboard. Yeah, so is stable with brick removed. K-Jot, thank you for the follow. K-Jot, you're not a jot, it is K-Jot. Thank you for following me. Thank you for the follow. We chat for Fires. We already chat on Discord. Gotcha. Well, Fires, were you over on Pirate Software's Discord? Is that how I know you? Or maybe we chatted a bit on Captain Coach Academy Discord. I'm not sure. But happy to see you. Happy. What the heck is that? Friday. I can't even think today. Tola says. With Dark Tonic, gotcha. Tolas, if that's the 3 drivers and why is the answer 5? It fills. Anything removed would make others fall except for the top one. I'm confused. Okay, so let's look at this. If we remove the bottom one, these fall. If we remove this one here, so it's saying which ones are safe to remove. This one clearly is not safe to remove. This one can be removed because these two are supported by this here. I'm assuming this one is 3 wide. I'm not 100% sure. This one I believe is also 3 wide. If we remove it, these two are supported by this one. So we have 2 that can be removed. If we remove this one, this guy's supported here. If we remove this one, this guy falls. So we have 7 minus 2 is equal to 5, right? So we should end up like that. But Fires, I hope you're having a beautiful day. Welcome to my stream. We are working, all except the top is size minus 3. So we can safely remove all of them except for this one and this one. So that's 5. And so that is what I was trying to do here. And I'm doing something terribly wrong. And I'm so tired. I can't figure out what I'm doing. What about case where they hit the red block hard enough, it's slip free, and the whole tower just falls down and doesn't collapse? Look, we're living in a quantum environment, a Tetris-esque environment here. Honestly, I should just code this up in Unity. Quantum locked bricks. Yeah, if I just code it up in Unity, then I would be able to see what's happening. Take a step, see what's happening. I don't. Is stable with brick removed. Okay. So what if I change this to is unstable? If I make this is unstable, I can say count this brick as one that needs to be removed. Here. Okay. So I can say is unstable, count it. And then let me change my thought process here. We move this one down. If this is going to contain oh my goodness, why can't I think right now? Is stable with brick removed. If it is not stable with the brick removed, we should count this as a brick we need to remove. And then we should do our bricks dot count minus removable. Hang on. If it is stable with the brick removed, we need to go through. I don't think I'm going through all of. Okay, I think this is what's happening. I need to say bool is stable, true. I need to check every single brick. I think I'm leaving early. For every other brick, is stable with brick removed. If we remove this brick and it continues to be stable, we need to check another brick. No, I think I had it right before. We would do, if it is not stable, is stable, is false. And then we'll say if is stable, it's safe to remove it. But I'm pretty sure this is what I was doing previously. I don't think this changes anything. If I get 6 back, 1. Oh, and then this should, yeah, it's giving me back 6. I don't know which one I'm counting incorrectly. Yeah, it's Tetris Physics, Tuber Tugger. Let's try our debug again. Can I label these things? Let's do a quick label. Let's do a quick label on these. String array labels is equal to enumerable bricks dot enumerable dot repeat or range start at a bricks dot length count dot to string. What do I got back here? This is giving back int dot select x goes to care of x dot string join. Oh my god. There are labels. And then we can say, because that's how they label these in the example, right? A through G. Yeah, A is on the bottom. All right. Care removed label equals labels of IX. Let's just add more terrible code to check label. Bear in mind that won't work for the main input. Oh yeah, this won't work for the main input. Yeah, no, I'm just trying to debug. You are correct. You are correct. This will not work for the main input. I think I have a bug in my check disintegrate. Part of me is saying I hope I have a bug in my check disintegrate. Let's double check this tower as well, to make sure all the shapes in that. All right. Let's make sure my tower is correct here as well. Two check labels A. Oh. What? What is labels? A, B, C, D. Two check labels should be JX. Okay. I'm losing my mind, folks. I'm losing my mind. I need to draw this. My tower. I need to make sure my tower is correct. Hang on. I'm drawing it. Let's make sure. Let's pull in this guy here. What is the... I've done something. There we go. Bottom, we have 0, 1, 2, X. All right, so this is our X axis here. It looks like that is okay. Z is 1. All right. In our second one, we should have 6. X 0, 1, 2, 0, 1, 2. Y 0, 0, 0. Y 2, 2, 2. Is Z, am I doing up and down? Is Z the up and down axis? Is Z the up and down axis? Am I supposed to be doing the Y as the up and down axis? Okay. I was like, oh my goodness, am I doing this wrong? Because that's a little weird to have the Z, Y going like that. Okay. Z is up. 3 should have 6 as well. X is 0, 0, 0. 2 is 0, 0, 2, 2, 2. 0 and 2. X is this way. Y 1, 2, 0, 1, 2, 0, 1, 2, 3, 3, 3. Okay. A secret Val, welcome to the stream. I am used to Y being up in Unity, so for a second I was like, oh no. 4 should have 3. Y is 1, so it's 1 in, and 0, 1, 1, 4. And then we should have 1 in the center, and then 1 in the center. Okay, so my tower is correct. My tower is correct. So I'm correctly computing my tower here, so I can see where my bricks are. That's good. Let's unsticky this. I've stickied something else. There we go. I don't know what I stickied. Let's... Alright. To check is B. Let's pull that brick out. And I guess I could pull this in here still so we can see it a little bit more. Removed is 101 to 121. So we're removing this bottom one here. So we should break here. We should break here. Removable plus break. Nick, I'm losing. No, I have not. Or are you saying did you? You've done it. You've done it. I have not. I'm losing my mind. This is Mayhab. Welcome to Lurk. Not reading part 2 yet. I'll leave it for my next stream. I need to take a sleep, man. I don't know what I'm doing wrong here. And I'm losing my mind. Okay. So this one should not be removable. Okay. So the bottom one should not be removable. Because this should say it is stable. So if it is not stable, not removable. If it is not stable, it's not removable. Okay. When we get to the top, we're missing the last brick, the very last brick. Should always be removable. I think this is still incorrect because I was doing this is what I had before is it should say that we have 2. All right. And then we want to do, I think we're still not right. Bricks.count minus this. Yeah, we've tried 518, and this is not correct. Answer's too high. Let's do a crazy brute force. Not yet, Smab. Not yet. I'm too tired. I honestly think I should just go to sleep, and then when I wake up, I could probably solve this. I should have built this with just a dependency graph. Which is probably what I'm feeling like I'm going to need that in part 2 anyway. I wanted to brute force this through. Let's try one last thing. We're going to try one last Hail Mary. Let's say for each to check let's do a hash set of bricks removable equals new we're gonna removable is gonna be equal to our not to check of all of our bricks. All right, so let's go through all of our bricks. We're gonna start saying any brick can be removed unless we find one that can't. Okay. And then at the end of the day, we're gonna do, this is a crazy brute force. I'm doing nothing clever here. I'm gonna say for each brick, I'm gonna do an all pairs, all pair comparison. Brick to check in bricks for each brick to remove in bricks. And we're gonna say if it is not stable with this brick removed, if to check is equal to to remove, do nothing. Continue. Goob, welcome back to the stream. Thank you for the first. Congratulations on number 12. If we are not stable with this thing removed, removable dot remove to remove. If we ever find any spot where if we remove it, it doesn't work, we're gonna do that. This is like so over the top brute force that if it okay, and we're still failing. With 6, which makes no sense to me. I clearly have some sort of bug in here. With like removing my tower position somewhere. Yeah, there's something wrong with this. And I'm too tired to figure it out. I need to go sleep. I'm gonna go sleep, folks. If I'm filling up for it, I might stream later. I have found if I stream in the afternoon, very few people come. So I probably won't stream in the afternoon. I do need to get some sleep. We'll be back. I'm going to rewrite this using a dependency graph. So here's the thing with the dependency graph, it'll be so much easier because I can just say, hey, are more than one, for every brick, if it has exactly one brick that it depends on, don't remove the brick that it depends on. That's really what it comes down to. If I build up a dependency graph, and I'm assuming I need it for part 2 anyway, build up a dependency graph. It says every brick, how many bricks are holding it up. If it has exactly one brick holding it up, the brick beneath it is a brick that can be removed or cannot be removed. That's what it comes down to. So I'm going to build up a dependency graph. I got to get some sleep. I'm feeling kind of sick because I'm so tired. So we're going to find someone to raid. See if someone's doing admin of code. Thank you, McNets. Thank you, McNets. Let's see if we can find someone to raid here. Yeah, essentially that's what it is, Mizzard. If I had the dependency graph. Any suggestions on who to raid? Otherwise, I'm gonna try and find someone doing admin of code in English. This is a co-work. It doesn't look like we have many options. Not English. This one says co-working, so yeah, this one's not a participatory stream. Not English. All right. If we have any suggestions, let me know. We're probably gonna go raid Fritz. Yeah, we'll go raid C# Fritz. Thank you for the suggestion. Code Red Games. How long has Code Red Games been going, actually? Code Red is good. Let's see here. 5 hours. Been going for 5 hours. How about C# Fritz? An hour. Let's raid Fritz. He'll probably be on longer. Let's go raid C# Fritz. Incredible streamer, folks. All right. Thank you guys for being here. Let's make sure I get that right. Remember, keep coding, keep growing, be the best you can be. You're welcome back anytime. We'll be back for day 23 tomorrow. Have a beautiful day, everybody. Bye.